Basically, the challenge that development teams usually run into, and I've been a developer before jumping the fence and helping software developers secure their software, is that you have to scan the code, and vulnerabilities are becoming more and more prominent, and it's getting more and more complex to the point that you have to run different types of scanners. Nowadays, at a minimum, you have to run your static code analysis tools. They refer to as SAST. And then you have to run your software composition tools to figure out what vulnerable packages you may be using. That's the SCA category. Then you've got your dynamic testing, which is your DAS category. That's like 3 right there minimum. Then you add container scanning. You might add infrastructure as code scanning. You might add your cloud scanning. You run into 7 different scanners. And if you have multiple repos, what happens is you have to install these scanners per project or per repo. And then maintaining them and updating them and configuring them in multiple places quickly becomes a pretty big headache. So imagine at 5 repos, you have at least the three scanners in each. You got 15 scanners you got to maintain, update, configure, all that stuff. So what, and then that's just one side of the problem, is the configuration. And then the orchestration is another, running them all and that sort of thing. And then the other problem is that they each have their own portal often, or their own report. So let's say you have a modern scanner, it's got a portal like SNCC or something like that, and you got to go to every scanner's portal. So now you got a lot of different places to review the issues, and the issues are not normalized because each vendor presents it in the way they like to present it. So then, you're looking at one and the other, kind of doesn't make sense. And then it gets really erroneous, time consuming, and you start to actually miss real issues because it becomes so time consuming and a headache. And, I remember as a developer, it was like, these are the kinds of things you don't really want to do. And, and then there's a lot of false positives. So you get like this long list of issues, after all the other headaches that I talked about, and you have to go through those false positives and try to figure out what's a real issue and what's not. So enter this solution that we built. And, again, I, as a developer, I saw this problem. And then as a security person helping developers, I noticed that, a lot of folks had these challenges. And I was at a conference and then talking about this problem. The idea came about that there's a framework that helps you orchestrate different scanners. So we took that, and I rolled up my sleeves with a buddy of mine. We built a tool for a client, and next thing you know, almost 5 years later, here we are, and now it's a full-blown platform that runs in the Azure and does all kinds of wonderful things. And Conleth can give you an overview, but that's the problem we're trying to solve. We're trying to reduce the time that it takes to review all the scan results, be able to find issues a lot quicker by grouping things that are similar to each other. So instead of showing you 200 things, we group them into smaller, maybe 15 items that you can quickly just go through those 15, because 30 of those issues may just be very similar or related. So we make that triaging a lot easier, which helps you find the false positives a lot quicker and get to the back to the things you enjoy doing, building software, rather than spending all the time in security. So Con, let's take it away, my friend.
Sure, no problem at all. I'll just share my screen. So yeah, as Farshad mentioned, the product itself is kind of distributed via the Azure Marketplace. So essentially, do an install from there and walk through the full onboarding process. You'll get into the application, and the first thing you'll need to do is create your first project and then configure your scanners. So we tried to make it as simple as possible by giving you a list of scanners, allowing you to filter based on like your languages or the types of things you need to scan for. So SAS, DAS, SCA or the languages. So yeah, from the kind of like scanner configuration, we've abstracted it and kind of made it simple to follow, rather than kind of reading through all the documentation. We've put the configurations or the common configurations between all the scanners into, a similar kind of configuration page. So we have active and enforced. So essentially active means that it'll run, and enforced means that it's, build the blocking essentially. You can ignore issues. You can, mess with whatever settings you need to kind of mess with. As well for SAST, you can include like different rule sets for searching for different kind of, patterns within your code for different security vulnerabilities. And then DAST being like setting up a live server, and then essentially sending malicious payloads to your actual application and trying to find vulnerabilities that way. So yeah, I suppose after kind of configuring your scanners, the next thing you'd need to do is come to your integration section, select the DevOps platform that you're using, and then just follow the steps here. We provide some documentation if you haven't done this before. But yeah, essentially just follow these steps, go into your CI/CD platform, paste in your code, and generate some of your credentials and yeah, basically your login details. We do GitHub Actions. So the thing is, the actual agent, we call it, is done in Docker. So essentially, it's agnostic of like, the platform that you're using. We haven't put out the instructions for GitHub Actions, but something I'm familiar with. It's something that we use internally. So it's just a matter of kind of setting up the, I suppose, the pipeline build in GitHub Actions and using these steps here to kind of go through that. So the case of kind of Azure DevOps, you come in, go to an existing pipeline or create a new one, add in the steps to your existing or new pipeline, set up your variables for signing in and kind of sending your information to a storage bucket within your own subscription, and then running the scan. So essentially what happens in the back, the back end of this, is it pulls down from a container registry, pulls down the configuration file from a storage account, runs your scanners sequentially, and then does some ETL on the results of the scanner. Once the scan is completed, you just come into your projects, go to your dashboard. So go ahead.
So Justin, that could have been any CI/CD platform. Like as Conleth was saying, it's just a Docker container that gets downloaded based on here in this portal where Conleth was showing like which scanners you enable. And that's the basis that is used to put together dynamically a container for you that runs on your build agent. And you can see here in this dashboard which scanners were enabled. You can see all of these ones that are enabled for this particular project, and then what issues each of them, how many issues each of them had found, when the scans ran. And then right from here, you can go and edit. Either you can edit the scanner configurations from here, or you can go down to project settings. You can also edit them there. And it also shows you a historical graph there of the issues found over a period of time. So ideally, you want that to go down. You want it to go up. So, but yeah, Conleth, go ahead.
So yeah, after the results kind of come into your client portal or your portal, essentially categorizes them into like different categories, essentially making it more easy to digest and kind of look through your issues. So you could see here maybe validation and sanitization is an area that you need to focus on and maybe improve some development practices there. And as well, just kind of putting it into a more consumable manner. So going into, let's say, logging and processing, you can see verify that all access controls have been logged. They should include requests and relevant metadata needed for security investigations. So essentially, this is using ASVS, which is a group of like requirements for your software to kind of follow. So essentially, from the results, we're able to map those over to ASVS items, and you can see what kind of items are failed. So yeah, we can see here that there's an npm express JWT issue. So click into it and then see the relevant details for that specific issue. So we can see it was found by mergebase, what deficiency it had. So it has a CD and CWE, where it was located in your application. So it was in the package lock JSON file, and it's this specific package that has the issue with it. So just gives you a general description of like what the issue is, and a remediation on how to fix it as well.
As you saw in the previous screen, I think we'd enabled a number of different scanners. So SAST, SCA, DAST. The one that Conleth was showing previously, that one was mergebase, which is an SCA. So that one, it looks for vulnerable packages and it reports the path there would be like where it actually found because those SCA, the SCA software, they look at package.json or the NuGet package, and then they find the vulnerabilities that way. So the path they're reporting is like, I found it here in this package file. It's also worth noting that, Conrad, go back to the previous screen. So one thing is you can filter here, like let's say you only want to see the SAST. Right now, there's two things that are interesting worth noting here. Number one, as Conrad was showing, these are grouped based on requirements. So that's really, really important. Because number one, this is using OWASP's application security verification standard, which is like the industry standard when it comes to appsec. They have the top 10, but the top 10 is not really a listing of requirements. It's just top 10 attacks that happen. This is like all the things you need to do to make your software secure. But it's sort of like test-driven design. You can use it also as a test case. It's like, hey, test to make sure that the application has no deprecated cryptographic algorithms. That's the test case. Requirement is make sure you build your software that doesn't have deprecated algorithms. So these things, what we do is when we find a vulnerability, we group them into that. So you can see, for example, number 5 validation categories, got 282 items, right? So if we weren't grouping them, you'd be looking at this massive page scrolling through 282 items. But in reality, 43 of them are all similar under input validation. So if you go there, you'll see that, oh yeah, there's only 4 requirements that they failed. So for the first requirement, there were 19 vulnerabilities that map to that. So this makes processing the stuff a lot easier. You're like, oh yeah, we had a whole 19 places where we failed in doing that particular, having that requirement. So it makes it easy to figure it out also from a threat modeling perspective. And because my recommendation has always been to software teams that, whenever you're overwhelmed by a lot of issues, try to figure out which ones can actually cause a threat scenario, that when you can link them, that if an attacker connected those ones together, they could actually attack your system. The ones that you can't connect together to attack the system or exploit, you can ignore those for now. They're low risk, deal with them later. I mean, it should be good practice. My other recommendation is if it's easy, just fix it. If it takes you like a few minutes to update that package or fix that thing, just do it. Doesn't matter what the risk level or if the threat scenario is. But in a lot of times, it's not the case. So here you can just go and look at, it's a simpler view. You look at which requirements you failed and then figure out how, if any of those requirements can be linked together to cause an exploit, then just go and fix those vulnerabilities. We are adding another module in the near future, in the next couple of months, that's going to allow you to do that visually. So you can just drag and drop those similar requirements and then visually be able to create that attack pathway really easily so that every developer can perform that activity and really save a lot of time not addressing things that don't really matter, if that makes any sense.
Awesome. So another thing that we do include is SBOM, and essentially is that it's basically your recipe book for your software. So I think the US government have started to require these as part of the software development lifecycle. So that's something that we provide, and I think Cyclone DX is becoming, I think, the standard as well from that. So we'll be supporting that soon. And as well, we allow you to kind of look through the actual raw scan results, and as well just to kind of see where different scanners passed, failed, or whether they're pending, and all that good stuff as well. I think then from the other perspective, I think we have an integration with Jira as well. So we don't want this to become like another system where you manage tickets. We want to push that directly into your own kind of issue tracking system so you can manage them there. So yeah, that's an important part of, I suppose, the process as well. What is going to change over the next while is that we are going to go with a system approach rather than just projects. So at the moment, we currently just scan repos. We want to kind of build it into a whole system. So a lot of the time there's different repos that feed into a larger system, and we want to threat model from a system perspective as well. It's great that you're fixing issues within your own project, but from an attacker's perspective, they're going to look at the entire lay of the land and try and pick the vulnerability from this particular part of the application and this part of the application to kind of traverse through the system and exploit it.
Yeah, that's a big problem industry wide, because a lot of people just look in silo. They'll just run the scanner in one repo without really considering how issues, because then ultimately when you build the system, you might be building components for multiple repos and you put it all together. It might be cloud infrastructure. Maybe your infrastructure is code as in one repo. You got different services and different repos, but it all comes together as a system, and attackers will pivot. The classic one is the Capital One attack, and it was 4 or 5 years ago, where they first took advantage of a vulnerable package, and then on that Nginx box, and then they pivoted into the machine, took advantage of an AWS with the metadata endpoint vulnerability, and then they took advantage of a misconfiguration in the environment. So there are multiple pieces that were all put together. So if you're not looking at that threat scenario end to end, you might be like, well, that's not important. I'm not going to update that package. Where are they going to go? Well, when you combine those 3 vulnerabilities, this is where they're going to go. But you got to have that overall perspective across the entire system to be able to do that. So that's what we're trying to build into this platform.